Next chapter, area. Area is the space occupied by a plane figure in 2 dimensions. We will first look at how to calculate the area of combined shapes. We already know how to calculate the area of rectangles and squares. To get the area of combined figures, all we do is divide the shape into familiar plane figures like squares, triangles, and rectangles. For this shape, the easiest way will be to divide it into 2 rectangles. Because these 2 rectangles, I have cancelled 2 and 7 centimeters because these 2 measurements do not apply to our new rectangles. The top rectangle has a length of 6 centimeters and a width of 4 centimeters, and the bottom rectangle has a length of 4 centimeters and a width of 3 centimeters. Area of the top rectangle is equal to 6 times 4, which gives us 24 centimeters squared, and the bottom one is 4 times 3, which gives us 12 centimeters squared. Area of the whole shape is the sum of the two, 24 plus 12, and that gives us 36 square centimeters. Area of a triangle. Triangles are perhaps the most important geometrical shapes we have. You will never hear the end of triangles. As simple as they may look, triangles carry very complex information. Previously, we saw that the area of a triangle is calculated as a half base times height. 2 quick things before we get further on. 1. When we label the sides and vertices of a given triangle, we do not do it randomly. This triangle is named on the vertices A, B, and C. The way we label the vertices dictates the way we label the sides. Vertices are named using capital letters, but the sides are labeled using small letters. Side A is the one opposite to the vertex A, this one. Side B is the one opposite to vertex B, and C is this side opposite to vertex C. Secondly, when we use the formula a half base times height, how exactly do you tell which is the base and which is the height? For triangles like these ones, it is very easy to tell. But an obtuse triangle like this one, you see, you can choose any side to be the base, and that should then dictate where the height is. In general, h is the perpendicular distance from the base to the third vertex. In certain cases, the height is outside the triangle. For instance, if you chose QR to be the base, then the height is here. Notice that the base remains the length QR and does not include the extended part. If you chose PR to be the base, this is the height. If you chose PQ, then the height is this length. In fact, the correct name is perpendicular height. And so for this triangle, area is equal to a half times 6 times 4. Notice that 6 is the base. That gives us 12 square centimeters. Area of a parallelogram. A parallelogram is a quadrilateral in which each pair of opposite sides is parallel. That also means the opposite sides are equal. The area of a shape is a measurement of the region bounded by a closed plane, or in other words, the area within the lines of a shape. This is a parallelogram ABCD. Based on our definition, AB and DC are parallel. We also know that AD and BC are parallel. Another feature of a parallelogram is that adjacent angles are supplementary or add up to 180 degrees. So angles ADC and BCD are supplementary. The area of a parallelogram is given by the formula area is equal to base times height. The base of a parallelogram is typically the longer pair of sides of the quadrilateral. So for this parallelogram, the base is 10 centimeters, but 5 centimeters is not the height. One thing to remember is that the height of a parallelogram must be perpendicular to the base. The height is the distance between the parallel lines and can be placed anywhere inside or outside the figure as long as it's perpendicular to the base. In this parallelogram, the height is 4 centimeters, so the area is 10 times 4, which gives us 40 square centimeters. Let me help you visualize why the area of a parallelogram is given by base times height. When I placed the perpendicular height here, I created a triangle, the blue region. And because this angle and this angle are supplementary, I will lift the triangle and connect it to the other side here. Now we have formed a rectangle ABCD with the height of 4 centimeters, a length of 10 centimeters, and therefore an area of 40 square centimeters. So when we use the formula for a parallelogram, we are actually calculating the area as though the parallelogram were a rectangle. Next, area of a trapezium. A trapezium has only one pair of parallel sides. If the parallel sides measure A and B respectively, and the perpendicular distance between them is h, then its area is given by the formula area is equal to a half into A plus B times height. And so working with the real measurements, suppose A in this case is 6 centimeters and B is 10 centimeters, h is 5 centimeters, we can calculate the area of this trapezium. Area is equal to a half into 6 plus 10 times 5. That gives us a half times 16 times 5, and that gives us 40 square centimeters. Suppose we have this kind of a trapezium. We do not know the perpendicular height, but we can find it. If you drop a perpendicular here, the distance TS is equal to 9 minus 6, that is 3 centimeters. The perpendicular height has completed a right-angled triangle. Using Pythagoras' theorem, h squared is equal to 5 squared minus 3 squared. H squared is equal to 16 and h is equal to 4 centimeters. And so the area is given by a half into 6 plus 9 times 4 by 2 1 by 2 2. 15 times 2 is 30, and so the area of this trapezium is 30 square centimeters. Area of a circle. Now consider a circle with center O and radius r. The area of the circle is given by pi r squared, where pi is 22 over 7 or 3.142, and r is the radius of the circle. That is the distance from the center to the circumference. And so for this circle, we are given the diameter as 12 centimeters. It means the radius is 6 centimeters. Area is equal to 3.142 times 6 times 6. That gives us 113.112. O is the center of a circle. A and B are 2 points on the circumference. APB is an arc of the circle. OA and OB are 2 radii of the circle. The portion of the circle is bounded by 2 radii and an arc. This portion is called a sector of the circle. In this figure, the sector is bounded by 2 radii, OA and OB, and the arc APB. This sector is named as AOPB. The angle subtended by an arc at the center of the circle is called the central angle. It is denoted as theta. If theta is less than 180 degrees, the sector is called a minor sector. If theta is greater than 180 degrees, the sector is a major sector. If theta is 180 degrees, the sector is called a semicircle. If theta is equal to 90 degrees, the sector is 1/4 of the circle and it's called a quadrant. We can calculate the area of a sector of a circle if we know the radius of the circle and the central angle. The area of the sector is proportional to the area of the circle. The central angle is proportional to the angle in a circle. Therefore, area of a sector over the area of a circle is equal to theta over 360 degrees. If we do cross multiplication, area of a sector times 360 degrees is equal to theta times the area of a circle. If we divide both sides by 360 degrees, area of a sector is equal to theta over 360 degrees times the area of a circle. Area of a circle is given by pi r squared, and so area of a sector is equal to theta over 360 times pi r squared. For example, given a circle of radius 6 centimeters and a central angle of 140 degrees, we can find the area of the sector OAPB. Area is equal to theta over 360 times pi r squared. That is equal to 140 over 360 times 22 over 7 times 6 times 6. And so we remain with 22 times 2, which is equal to 44 centimeters squared. In another example, a sector of a circle subtends an angle of 120 degrees at the center and has an area of 462 square centimeters. Calculate the length of the arc. In the solution, we know that arc length is equal to theta over 360 times 2 pi r. So to be able to calculate this, we need to find the radius first. Recall the area of a sector is equal to theta over 360 times pi r squared. And so 120 over 360 times 22 over 7 times r squared is equal to 462 square centimeters. By 121 by 120 is 3. And so we shall have 22 times r squared over 3 times 7. That gives us 22 over 21 r squared is equal to 462. To remain with r squared on one side, we multiply both sides by 21 over 22. So by 22 by 22, 21 goes with 21. 462 divides into 22 21 times. So we remain with r squared is equal to 21 times 21. We do not have to complete 21 times 21. We remain with r squared is equal to 21 squared. And so r is equal to 21 centimeters. Arc length is equal to 120 over 360 times 2 times 22 over 7 times 21. And that gives us by 121 by 123, by 31 by 37, by 71 by 71. That gives us 44 centimeters. Surface area of solids. Surface area of prisms. Prisms are solids that have uniform cross-section. They are named according to the shape of the cross-section. That said, this is a triangular prism. A cylinder is a circular prism. This is a trapezoidal prism, and a cuboid is a rectangular prism. Surface area is the total area of all the faces making up the solid. We start with the cuboid. A cuboid has 6 faces, and so we will work out the area of all the faces and add them up together. We have a rectangle at the front with a length of 4 and a width of 3. And there are 2 of them. Then there is a rectangle on the side, and of course on the solid it looks like a parallelogram. And there are 2 of them. Then the top rectangle and the bottom one, and they measure 2 by 4 centimeters. So now we calculate the area of all these faces and add them up. All are rectangles, and so area is length times width. So this is 3 times 4, that gives us 12, and there are 2 of them, that makes it 24 square centimeters. Then these blue ones, 2 times 3 is equal to 6, 2 of them makes it 12 square centimeters. This is 4 times 2, that is 8 square centimeters, but there are 2 of them, and that makes it 16 square centimeters. And so the total surface area is 24 plus 16 plus 12, and that gives us 52 square centimeters. Next, we look at the triangular prism, and again we will separate all the faces and calculate the area separately, and then we add them up. It has this triangular cross-section. 2 triangles, they have a height of 10 centimeters and a base of 9 centimeters. We have these 2 rectangles, length 11 centimeters and width 12 centimeters. Lastly, another rectangle with length 11 centimeters and width of 9 centimeters. And now we can start. Area of the triangles, a half base times height. That's a half times 9 times 10, and there are 2 of them, and that gives us 90 square centimeters. These green rectangles, 11 times 12, and there are 2 of them, and that gives us 264 square centimeters. And lastly, this pink rectangle, 9 times 11 gives us 99, and it's only one of it. And so total surface area is 90 plus 264 plus 99, and that gives us 453 square centimeters. And then we go to the trapezoidal prism and do the same. We separate the faces. Trapezium making the cross-section, 2 of them. 1 base rectangle, a top rectangle, and 2 equal rectangles. This is 8, this is 4, this is 9, and length 8. The base is 13 by 8 centimeters. Trapezium is 13 at the bottom and 9 at the top. Okay, now we calculate the areas. This blue rectangle, 8 times 9 is 72 square centimeters. This is 4 times 8 and there are two of them, gives us 64 square centimeters. The trapezia area is a half a plus b times height. That gives us a half 9 plus 13 times 10, and there are two of them. That gives us 220 square centimeters. Lastly, the yellow rectangle, 13 times 8 gives us 104 square centimeters. Total surface area, 72 plus 64 plus 220 plus 104 gives us 460 square centimeters. Lastly, surface area of a cylinder. Now I need us to understand how we find the surface area of a cylinder. To do that, we will separate the cylinder into three parts, just like we did with the other solids. And if we do that, we obtain two circular shapes and a rectangle. The area of each circle is pi r squared. And now the length of the rectangle is equal to the circumference of the circle. Recall that circumference is equal to 2 pi r, and this is equal to the length of the rectangle. The width of this rectangle is of course equal to the height of the cylinder. So area of the rectangle is length times width, that is 2 pi r times h. Putting all this together, we get the surface area for a cylinder. That is equal to pi r squared plus 2 pi r h plus pi r squared.
And so the biggest secret, or the biggest piece of advice, is get help early from as many people. And there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.